Hi, welcome to the Battery Management System session. Battery Management System or BMS is an electronic control system which is designed to monitor and manage the battery pack in electronics vehicle. It performs several key functions. Those key functions are performed by using the measurement taken from voltage and current and thermal readings from the battery pack. The battery pack consists of collection of cell of batteries. Individual cell thermal level, voltage level, current levels are measured by the BMS system, and through the measurement, the capability estimation, state of charge, state of health, and thermal management is carried out. These values estimated is communicated through CAN bus controller. It also estimate the cell balancing, whether all the cells are balanced or not. Let us see the detailed description in coming slide. So this BMS system uses various sensors and algorithm to measure and control the parameter in the system. Number one, the cell voltage monitoring. It measures individual cell voltage to ensure balance across the pack of the battery. The purpose is to detect weak cell or imbalanced cell that can lead inefficiency and potential safety risk. So we have to see that every cell in the battery pack will be producing uniform output voltage. Otherwise, some weak cell present, it will produce some different voltage which to be removed. The diagnostic tool used for that is voltage sensor on each cell, and there is an alert trigger system in the BMS system. Whenever the voltage level in a particular cell is deviated beyond a threshold value, it is creating an alert. The second process, current monitoring. It is track the current flow in and out of the battery pack. It is used to detecting overcurrent event which can damage the cell or shorten battery life. So we can use this current flow measurement to find out the overcurrent event and battery life estimation. The diagnostic tool used for that is current sensor. Usually Hall effect or shunt resistor based sensors are used. Temperature control and monitoring. Under this, the BMS unit monitor the temperature at various points within the battery pack. It is to ensure the cell remain within an optimal temperature range for safe operation. If the temperature exceed, also the problem. The temperature is less within the pack, also the problem. So it has to monitor and checked with threshold value. The diagnostic tool used for this temperature control and monitoring is thermistor or any temperature sensor. The data coming from these sensors are fed into the cooling system to adjust the temperature. SOC and SOH. So SOH, state of charge, measure the energy left in the battery. What is the remaining energy left in the battery, which is very essential estimate in order to operate the electrical vehicle safely. And also it measure overall health, SOH, state of health. The purpose to calculate these two parameters to provide driver and the system with an accurate reading of remaining charge or battery health. The diagnostic tools used for this estimates are coulombs counting, what is the coulomb charge level is available, that counting, and voltage based SOC estimation, aging model for state of health estimation. So you can use coulomb counting, that is number of charges left out in every cell, and you can sum up and you can find out state of charge, or you can do voltage based SOC estimation based on some algorithm. And for the case of state of health, we can use some mathematical model or aging model for state of health estimation. Charge discharge cycle and capacity monitoring. This process is carried out in BMS to track the number of charge discharge cycle in order to estimate the battery degradation. the battery suppose started to degrade, the charging and discharging cycle will be different from the normal cycle, so which to be detected, and alert should be given to show the user the battery started to degrade. It is also used in estimate of state of health assessment. The diagnostic tool used for this is internal algorithm which track the cycle count and capacity fade over time. Fault detection and error logging, that is another job done by BMS system. It records the fault such as over voltage, under voltage, over current, and any communication fault. The purpose is to provide diagnostic data for troubleshooting and ensure the safety. The tool used for this purpose is the internal diagnostic software within the BMS with a data logging capability. There are common BMS related fault. Fault number one, cell voltage imbalance. As already we discussed, uneven charging and discharging rate across the cell will create cell voltage imbalance. For that, we have to monitor individual cell voltage and you have to look for the imbalance. You have to identify the cell which create imbalance voltage and you have to remove and replace it. Temperature anomaly, overheating or underheating during the operation. For this, we have to track temperature across every cell and also the cooling system, whether the cooling system functioning or not. SOC SOH estimation error. There may be inaccurate SOC SOH calculation for estimating remaining charge and health. For that, we have to analyze the calculation method and algorithm, the correctness of it. Overcurrent, over voltage. There will be sudden power loss, reduced battery life, that is the indicator. We have to monitor voltage and current trends for such detection. Communication fault. BMS unable to transmit data to EC unit. For that, we have to check the CAN bus other communication channels. Charging fault. Battery not charging fully or overcharging. Under the case, we have to inspect charging parameter, monitor for error. Thermal runaway. Excessive heat, possibly battery damage. Analyze temperature spikes and monitor cooling system again.